Hello. This session is about prescriptive analytics and the relation between prescriptive analytics and artificial intelligence. Prescriptive analytics suggests decision options to take advantage of the result of prescriptive and predictive analytics. It goes beyond prediction and beyond predicting the future outcomes to also suggest actions to benefit from the prediction and showing the implication of these decisions options. It starts with understanding the question of what is likely to happen. This is when historical data is combined with rules, algorithms, and occasionally external data to determine the probable future. And then it suggests action and shows the future effects of these options. Prescriptive analytics based on artificial intelligence is designed to handle large, heterogeneous, complex data sets. It is aimed to learn patterns from these data sets based on a set of mathematical rules and statistical assumptions. So the aim of the learning process is to develop a predictive model among features discovered in the given data sets. It sifts through volume of data to find hidden patterns and more precisely hidden predictive patterns. These patterns learned from the training data sets are then applied to a new data set in order to make prediction on likely outcome. So the large, highly complex data sets present the raw materials needed to gain insights. The potential of these data can only be realized through higher level analysis. So the input consists of continuous categorical, binary features and labels. Of course, features are the measurements across all samples, either raw or mathematically transformed. Labels are what the model aims to predict. So the workflow is and can be summarized in 5 stages: extracting and collecting, curating, ingesting, training, and testing, finally analyzing and predicting. So we'll focus on these 5 stages. The stage 1, extracting and collecting the corpus of knowledge. In this first stage, we will focus on how to extract and collect the corpus of knowledge. Compared with the body of knowledge that represents the complete set of concepts and knowledge related to a specific domain, the corpus of knowledge is concerned only with the most relevant information and knowledge. So during this first stage, information system experts will first learn the language and the jargon of the principal thoughts of the domain. For example, if they are working in marketing, they will learn what is the image, what is all the marketing rules and concepts. And then these rules will guide the concept of collecting, extracting the unstructured and structured knowledge. So this method is used to extract structured, tacit, and explicit knowledge and other data obtained through interviews and by searching to understand all the published reports and all this. The second stage is related to curating the content. So creating the content phase can be defined as the process of gathering, organizing, sorting individual knowledge and group knowledge and organizational knowledge in a vast volume of knowledge. And this consolidated knowledge can be represented in meaningful formats. So many activities occur during the process of creating the content. First, for example, database design expert must start to aggregate the knowledge that is relevant to the explanation and prediction. Second, they have to deal with the distillation of knowledge in a simplified format that shares only the most relevant and important knowledge. Third, they execute many mashups, which creates new organizational knowledge resulting from merger of distillated knowledge and content. Fourth, they finish with the elevation, which identifies the significant trends that has emerged from exchange of knowledge. The combination of individual knowledge help creating a collective knowledge, collective intelligence, and while reducing precisely the dimensionalities of data. This enables the AI algorithm to operate faster faster and more efficiently. The stage 3 concerning the ingestion. So the stage 3 will deal with data. Data from different databases were processed and represented in new structure. Properly formatting, cleaning, and normalizing the input data is a must. Therefore, process the input data is a key to the entire process. Not every input feature in a given dataset will be informative for predicting the output labels. Including irrelevant features can lead to overfitting the model. Feature selection can be used to identify informative features. Dealing with data includes inferring the missing values by imputing, for example. This stage allowed the transformation of curated data while cleaning it and filling missing value. Ingestion allowed building an indices, metadata that can work with curated content more efficiently. And the knowledge graph is also created to assist in answering precise questions. The stage 4 is about training and testing. It's the abductive part of the process, and it led to multi-agent. It will lead the multi-agent to learn specific rules and instances in the data. So the AI multi-agent will learn by running the algorithm repeatedly through the training set until it found predictive vector, which is the correct on the majority of the training set. Then training the underlying model must be conducted. Training refers to a series of back and forth steps that aims at finding the optimal set of model parameters that translate the features in the input data into accurate prediction of the labels. After many evaluation, errors identification, correction, and test, the model performance reaches its optimal and the error will be the lower. So the model is said to have been properly learned. Sometimes when the model is too complex and too simple, overfitting or underfitting the model occurs. Overfitting happens when the trained model succeeds in predicting the trained data with high accuracy while failing to make predictions on the test data. Underfitting occurs when the model does not accurately predict the training data. Overfitting can be addressed by increasing the size of the training data or decreasing the complexity of the model, while underfitting can be addressed by increasing the complexity of the model. The prediction accuracy of the AI algorithm is measured by dividing the number of correct predictions by the total number of predictions. As the problem is complex, the decision is to construct several subsystems that use different machine learning strategies to gain power to analyze the questions and arrive to the most likely answer. In this part of the training, the technique used is to split the training set by using a part for training and the other part for estimating and predicting the accuracy of the model. When the error rate is unsatisfactory, database design expert must return recursively to previous stages 1, 2, and 3, because it meant that relevant features for the model were not fully captured. Managers play an important role in teaching the multi-agent how to interpret the information, how to select the best responses, and how to acquire the ability to find patterns. So questions-answer pairs are also generated in order to obtain and in order to train the AI multi-agent to generate high-quality answers. In stage 5, analysis and prediction. So based on specific questions, the multi-agent will generate hypotheses, looks for evidence to support or refute these hypotheses. And then he will score each passage based on statistical modeling known as weight of evidence score. The confidence of AI multi-agent answers is estimated based on how high the answer was rated during the evidence score ranking, which allows the agent to make better and more informed decisions. Thank you very much, and see you in the next video.